Yo, 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 yo. Hey, guys. So, we're going to talk about experimental probability of simple events. So, what we're going to do is we're going to use experiments to find the probability of an event happening. So, we're going to use the results of an experiment to figure out what is the probability of something happening. So, it might not be necessarily the actual probability, but it's going to be the experimental probability. So, what that is, experimental probability is still a fraction, just like what we learned in 12.1. If you've not watched 12.1 yet, please go and do so now. So experimental probability is this, we're still writing it as a ratio, which is a fraction, of the number of times the event occurs to the total number of trials. That formula should be in your notes, and it's on the next slide. A simple event is an event that just has one outcome. Kind of like when we roll the dice, that's a simple event. We just roll the dice once, that's a single outcome. There's only one possible thing that can happen as a result. So here's what I mean. Here I have my formula for experimental probability. So for any experiment, we take the number of times the event occurs and we divide it by the total number of trials. So how many times do we conduct the actual experiment? This is how we conduct the experimental probability. So here's what we mean by this. Martin has a bag of marbles. He removed one marble at a time, recorded the color, then placed it back in the bag. So he's just kind of doing this at random. He's not looking in the bag. He's not cheating. He repeated this process several times and recorded his results in the table. Find the experimental probability of drawing each color. So what we're going to do is I need to know the number of trials. So he's conducting his own experiment, and so because of that, I need to know how many trials did he conduct. Well, here's his table in which he recorded his data. He drew a red marble 12 times, he drew a blue marble 10 times, a green marble 15 times, and a yellow marble 13 times. So this frequency right here is how many times he drew marbles. And so I need to add up all of those values in order to know how many trials there are. That's always the first step. So I can add them up. 15 plus 13, 12 plus 10, that's 22, plus 15, that's 37. So he did 50 trials. So my total number of trials was 50 because I decided to add all of those up. I don't need these arrows here because that's how many times he pulled the marble. That's how many times he conducted his experiment. Okay, so now that I have my probability here is 50, I know my total number of trials is 50, the probability for each one of these, because that's what it's asking us, find the experimental probability of drawing each color. Well, my probability is going to be 50 each time. Here's what I mean by that. I want to make this a little bit bigger for you guys. So, because that'll make it easier for me to write. That's better. So here's what we know. If I know the number of trials is 50, then that means that's my denominator, every single probability for all of these colors. Because out of 50 trials, the probability of drawing red was 12. The probability of pulling a blue one was 10 out of 50. The probability of pulling green was 15 out of 50. And the probability of pulling yellow, I won't draw yellow just because you won't be able to see it, was 13 out of 50. So I use the same denominator because that's the total number of trials. And the times that we drew red, well, it was 12 out of 50. We drew 10. We drew blue 10 out of 50. Green 15 out of 50 times, and yellow 13 out of 50 times. So by this experiment, these are all my probabilities. And of course, I have to simplify. So 10 out of 50, this really becomes 1/5. So blue is 1/5. So I can divide these both by 10. 12 out of 50, I can divide them both by 2. And that becomes 6 out of 25. Because I'm dividing 12 by 2, 50 by 2. 15 out of 50, I can divide them both by 3. By 5. And 15 is going to become 3 out of 10. And then the yellow cannot be simplified because 13 is a prime number, so I'll write that in orange. And that's 13 out of 50. So that is all of my probabilities for each color. Added up the total amount of trials. That was my new denominator, and I just put the number that we have here in the numerator. Okay, so the spinner has 3 unequal sections. They're unequal. Okay. Red, yellow, and blue. So they're not the same exact size. The table shows the results of Nolan's spins. Find the experimental probability of landing on each color. Write your answer in simplest form. I think you guys can try this one on your own. Try it out. Pause it. See how you do. Okay. So for red, first we have to figure out the total number of trials. So I have to figure out, well, what are my total amount of trials? I got to add all these up. Okay. 10 plus 14 is 24 plus 6. There are 30 trials total. So I know my denominator for red is 30. I know my denominator for yellow is 30. And I know my denominator for blue is 30. Because that's how many trials there were total. Blue was 6 out of 30. Yellow was 14 out of 30. And red happened 10 times out of 30. Now we can simplify that. That's 1/3. This becomes 7 out of 15, and blue becomes, I can divide by 6, 1/5. And I am done. So those are all of your experimental probabilities. You have a 1/3 chance to hit red, 7/15 chance to hit yellow, and 1/5 chance to hit blue. Okay, to play a game, you spin a spinner like the one shown. You win if the arrow lands on the arrows marked win. So you got these two small win sections. You got the big section that's not win. Lee played this game many times and recorded her results. She won 8 times. So she won 8 times. She lost 40. So I'm writing down what's going on here. So she won 8 times, lost 40 times. Find the experimental probability of not winning. The experimental probability of not winning. So of not winning, that would be losing. So of not winning would be losing. So I want to know, what's the probability that she lost? Well, she lost 40 times. How many total trials were there? Well, this is where we add them up. There's a total of 48 trials. So that was 40 out of 48. I would simplify this now, because I can divide this by 8. The probability of not winning was 5 out of 6 times. I took the total amount of trials, which was 48, figured out the probability of not winning, which would be losing. That was 40, because that's how many times it happened. Boom. Dunzo. All right. That is it. Things to remember. Always add up total trials first. It's probably the number one mistake. Always add up the total trials first. And then that goes in your denominator. Always add up the total trials first and then put those total trials in your denominator. If we can set it up like that, we have a pretty good chance of being successful. Okay, guys, that is all I got for you guys. Get your independent practice done. Thank you for watching. If you have any questions, please let me know. Good dias.